Points A and B lie on a circle with center O and radius r centimeters, where angle AOB is 1.5 radians. The area of sector OAB is 48 centimeters squared. Question A, find the value of r. So, since it is given the area of a sector, we can consider what is 48. And a formula for the area of a sector is given in a data booklet, and it says that it is equal to a half r squared theta, where theta must be in radians. It arises from that area of a circle is pi radius squared, and a sector is just a part of a circle, and it should and hence it should be multiplied by angle theta, and when theta is in radians, it should be divided by the angle of full revolution, which also should be in radians, which is 2 pi, and hence you can see that pi cancels and we get a half r squared theta. And when theta is in degrees, it becomes pi radius squared theta in degrees divided by 360. So we can say that it is equal to half r squared and multiplied by 1.5. Hence r squared is what? 48 times 2 divided by 1.5, which is 96 over 1.5, which is 64, and hence r is the square root of 64, which is 8 centimeters. And question B, hence find the perimeter of sector AOB. What is perimeter? It's OA, which is radius, plus OB, which is also radius, and plus the length of this arc AB. And how to find the length of arc? Formula is given in a data booklet, and it says that it's r theta, and theta must be in radians. And it arises from 2 pi r, its circumference, and length of the arc is just a part. So it should be multiplied by theta, and when theta is in radians, it should be divided by 2 pi, and hence you get that we get r theta, where theta is in radians, and when angle is given in degrees, it becomes 2 pi r multiplied by theta in degrees divided by 360. So the required perimeter becomes radius, which is 8, plus 8, plus the length of the arc, which is what? R theta, r times 1.5. Hence it becomes 12 plus 8 is 20, plus 8 is 28 centimeters. The next, the following diagram shows triangle ABC, where AB, BC, and AC are given, and the angle ABC is 2 theta. Find the exact value of cosine of theta, giving the answer in the form P root 2 over Q, where PQ are positive integers. So we can see that there are 3 sides and angle. How can we connect 3 sides and the angle? Just using the cosine rule. Formula is given in data booklet, and it says that AB, and it says that cosine of the angle C is equal to A squared plus B squared minus C squared divided by 2AB. And notice that this angle C and this side C with minus are opposite. So here it becomes cosine of 2 theta is equal to 4 squared plus 6 squared minus 5 squared, because this angle and this side with minus are opposite to theta, and opposite is 5. And divided by 2 times 4 times 6. And it becomes 16 plus 36 minus 25 over 2 times 4 times 6, and it's what? 11 plus 16 is 27 over 2 times 4 times 6, and we can divide by 3 to get the exact. So it's what, 9, and 2 times 2, 4 times 4, 16. So it's 9 over 16 as exact. Then we need cosine of theta, but theta and 2 theta are what? 2 theta is what? It's just a double angle, and we know a double angle formula. It is also given in a data booklet, and it says that cosine of 2 theta is equal to cosine squared of theta minus sine squared of theta is equal to 2 times cosine squared minus 1, and it is equal to 1 minus 2 times sine squared of theta. And to get this from this, it is used just the main trigonometric identity, sine squared plus cosine squared is equal to 1. And since we need cosine, and cosine of theta and cosine of 2 theta is given, we can use this directly. So cosine of 2 theta is equal to 2 cosine squared of theta minus 1. It is given in a data booklet directly. Hence, cosine squared of theta is equal to what? Cosine of 2 theta plus 1 over 2. And hence it becomes 9 over 16 plus 1 over 2. And common denominator in the numerator, and it becomes what? 25 over 16 and 2 in the denominator. I keep the exact because we need in such form as exact. And hence cosine of theta is, since it's cosine squared, it's like an equation when you meet x squared is 100, x is plus minus root of 100, it's plus minus of 100, so there are two roots. And here in general also there are two possible solutions, plus and minus. But what should we choose? So you can notice that 2 theta is opposite to 5, and this angle is opposite to 6. And we know that for opposite, for greater length of side, there will be the greater opposite angle. And if 2 theta would be obtuse, so greater than 90, this angle A will be larger, also greater than 90, and then the sum of 3 angles of a triangle will be greater than 180, which is impossible. So 2 theta is less than 90, it's acute. It's acute, hence theta is also acute, less than 90 is the first quadrant, and cosine for the first quadrant or for acute angles is positive. I don't know, can we write directly that it is positive, but it would be better to explain. So we can say that in general it's a plus minus square root of 25 over 16 multiplied by 2, and we can then say that it's plus and explain that as angle A is greater than 2 theta, so 2 theta is less than 90, so cosine of 2 theta is positive, so cosine of theta is also positive. I don't know, it may be acceptable to write that cosine is positive directly, but in general we can say like this. And then cosine of theta is just root of 25, it's 5, divided by root of 16 is 4, and there is root of 2 in the denominator, but we need in such form root 2 should be in the numerator, and we can multiply the numerator and the denominator by root 2 to get 5 root 2 over 4 times 2, which is 8. So it's the required value of cosine of theta. And that's all for this question.